Okay, so this lesson is solving rational equation. So lesson number 22, unit 2. So if you see the first part is, well, so the first part is what do you see and what do you notice and what you wonder. Okay, so you can clearly see there is a on this side there is a x minus 2. On the right side there is x minus 2. So that is called least. I want you to write this. What is the meaning of least common denominator? So you guys all heard this word, least common denominator means we say LCD. Now least common denominator means uh, almost like saying LCM also, least common multiplier. In other words, if I have 8 and 3, so what is the least common multiplier for this is LCM for 8 and 3 is 24. That's because 8 divides 24, 3 also divides 24. And the next one, common multiple is 48. But among these, 24 is the smallest, least common. So likewise, least common denominator here we say LCD, least common. In this example is x and x minus 2. See, what it means is, if you see this, x divides this whole thing, and x minus 2 also divides this whole thing. That's what it means. So, question was, what do you see is, so you notice that the least common denominator is multiply on both sides. So, using the multiplication property. So, this piece is common, multiply both sides. So, once you multiply this both sides, x and x crosses out. So this x crosses out. Even the x minus 2 and x minus 2 also crosses out. On the right side, x minus 2 and x minus 2 crosses out. So what are you left with is they skipped one. There's one step missing here. And the step that is missing is, so this 3 stays, so that 3 will stay equals. This 2x plus 1 will stay as it is. Okay. And this x, which is right here, will remain. So what is the next is use the right distributive property. What is right distributive property means? The right side x is multiplied to both inside. So x times 2x. So when you multiply x and 2x, you get 2x squared. And then x times 1 is just a x. So this is what you're supposed to write. What you notice means, okay, these are the steps being taken. The next one, you use subtract 3 both sides. So subtract 3, I'll write here. Both sides basically means you're left with 3 and minus 3 goes away, you get 0, and 2x squared remains, and plus x, and so this is how the meaning of this, what you notice and what you wonder kind of thing. So what you wonder maybe, uh, what are the how the graph, you may be wondering what is this means to you, what does the graph, what does it represent, or maybe what is the domain and what are the axes that we should not be taking. So I'm going to show that also right there. If you see this, both sides, there are few x's which you should be avoid taking, because if you take x equals some those numbers, then you end up getting like let me show an example. In the first case, it is 3 over x and x minus 2. Remember, the left side was this. Just imagine if you had to plug in if you had to plug x equals 0, what do you get? You can see this will be reduced to 3 divided by 0 and 0 minus 2. And that will be 3 over 0, which is undefined. So this will be the undefined. So few things to be noted is not only x, so your domain should not be, so x should not take the value 0. That's what it means. See? Even though they did not ask us, I will just write down x should not be 0. And also you can see there's x minus 2 right here. X should not be 2 also, because the moment you have x equals 2, and what are these called is x equals 2 and x equals 0. Basically, earlier classes we've seen this, but you forgot maybe. They are called vertical asymptotes. Vertical, it means we don't have the value for x equals 0 and x equals 2. So that makes it the equation kind of unvalid, undefined, or maybe does not exist. There's no output. So that's the whole idea about this. Okay. I hope I made sense and to the whole thing. Well, it looks creepy. Like so, basically, you may say, what are the values? If you want to factorize this to this space, we will do this in the next activity, that is 22.3. Right now, we're not working on this. Let's see. So a student by name Jada, what she does is, I want you to work this missile, right? So she works on it. It means she solves this. What she does is multiplies both sides. So both sides, there's a x here and there's a x plus 1. So either side you multiply x times. So Jada does this, x plus 1. And on the left side also she multiplies x and x plus 1. Okay. So when you multiply this x plus 1 and the bottom x plus 1, this x plus 1 crosses out. So and on the right side, this x, that x and this x crosses out. So let's see what are we left with. So we are left with x, then 5x plus 5, and on the right side we have 5 into x plus 1. Let's use distributive property. So using distributive property here, you get 5, and x times x is 5x squared, and x times this will be 5x equals 5x plus 5. Now let's subtract, let's get everything on the left side. So subtracting 5x this side, subtracting 5x this side. So you get 5x squared, and that will cross out, equal on the right side. So this will be crossing out. See, both will go away. You get 5 here. Dividing by 5 here, you get x squared equals 1, and you can say x takes two values. So if you see this, next step is if x squared is 1, we have seen this earlier also, that then x takes the value plus minus square root of 1, and square root of 1 is 1 plus minus 1. So I'm writing all the steps just to show. So now the question is, which are the correct answer? So we have two answers, and the equation is 5x plus 5 divided by x plus 1 equals 5 over x. So this was the original equation, and you can see, can we take both of them? So these are the two solutions. We want to know which one is wrong and which one is correct. Is it x equals 1 is good, or is it x equals minus 1 is good? And you can plug it in and see what's going on. Now, if I plug in, just imagine if we plug in minus 1, what do we get? And if you put plug here and here, if you put this, so it becomes 5 times minus 1 plus 5 divided by minus 1 plus 1 equals 5 over minus 1. And you notice what's going on is this will be negative 5 plus 5 over the bottom is 0, and that does not make sense. So that student by name Jada, she did all this work, she got 0 over 0, and that's like doesn't make sense. That's because this is not a solution. It's not a part of the domain. First of all, you can't have x equals minus 1 because you can see in the denominator there is x plus 1. Basically, x cannot take the value of minus 1 because if you take x equals minus 1, it's going to give you a wrong answer. I mean, it's invalid. But x equals 1 is good. This one is correct. So x equals to 1 will, if we plug it in, it will work because if you put here, you can check. So let's check this out then. So if I put x equals 1 here, okay, and put a 1 here, and put a 1 here, look. So the answer becomes 5 times 5 plus 10. Okay, so we get 10 over 2 equals 5 over 1. And 2 divides 10 5 times. So you end up getting 5 equals 5. So what I'm trying to say is, so we get 5 equals 5, and that is good. That's correct. And this is what, so this is the solution. This is called extraneous. So there is one vocabulary word is used, extra, N-E-O-U-X, extraneous solution. It means even though it looks like a solution, but it is not. So that vocabulary word is so important. It means the graph, they cross each other. So this is one equation, and this is another equation. If you really want to see how nice it is, let me clean this whole thing. If you see this, the right side equation, the right side equation is a stretch because the parent function of, if it is just 1 over x, we know that it's there. You can see on the chart also in my class on the left side, the graph, this is the graph, okay? But so because it is 5, so it is like stretch graph. Maybe it is something like this, when it's like going this way. Maybe the graph is going to, that means when x equals 1, it is 5. That's what it is. So this is the point. This is the graph of the right side. But what about the left side? Even though they gave us this, you can see the left one. I can pull out, if I write the equation, you can pull out 5 and use the distributive property, and you get x plus 1. And you can see both x plus 1 on top and bottom. You can cross out this, and you're left with y equals 5. It means there is a uh, so there is so the whole thing reduces to a horizontal line. So it means like this. So it reduced to a horizontal line like this. Okay. So at minus 1. So what is the meaning of that? At minus 1. Suppose x equals minus 1. So this is y is 5, except at minus 1, it's like there's no point here, even though it shows the whole horizontal line, but at minus 1, it is undefined. So the line and this graph, they cross each other at 1. So this is part 1. So the solution is 1 and 5. When x is 1, it is 5. So do you have to graph this? No, I'm just trying to show what does this means. Mean it is the red graph of rational function. This is the stretched by scale factor of 5. But the left side, this graph is, even though it is a rational function, but somehow we end up getting this, and it's a horizontal line. So this and this represents almost the same thing, except it is undefined. So this is whole horizontal line, and this is horizontal line, except at -1, it is not valid. So a lot of mathematics there. If you go deep, we call it like a hole. This is so there is on the left this rational function. We say rational function has a hole. We say there's a word you use. What is the meaning of hole at x equals -1? Is because this thing crosses out. So these two factors up and down, they are the same. So the moment they cancel out, it means just there is no vertical asymptote for this graph. There is no vertical asymptote. So this graph, it is the y-axis. So I hope that makes clear what is the meaning. So the new word that you use that we understood today is what is the meaning of a hole and what is the meaning of asymptote. So you know already, but still let me show. Asymptote is like it can be here right now in this example. It is the y-axis is the vertical asymptote because on this piece 5 over x, the x is down, so that's why we say x equals 0 is the vertical asymptote. But the left side, even though some students think that why not -1? No, but then the top one also there is x plus 1, so they get crossed out. So when they cancel, there is no vertical asymptote at x equals -1. I hope that helps. Let's go to the last. All of you know, are you ready for more? What are the solutions here, right? So all you do is take the square root on both sides. So it means if I have x square is 1, so if you put take square root, which you've been doing in middle school also like this, but remember you have to do plus and minus. That's what it means. See. So it is not only plus. So and then you can say, okay, let's cross out x and say, okay, x takes two answers, plus 1. So it is plus and -1. So there are two answers. X is -1 and x is +1. What it basically means is there is a parabolic shape, there is a graph, square function like this, and uh, there is a 1. So y equals 1 basically means it's a horizontal line. It is a horizontal line, and they cross each other. So this is the understanding of when 1 is 1, it is 1, and when 1 is -1, also it is 1. So do you have to graph and all? No. This is just in addition to geometrical interpretation of the algebra. What we did here is algebra. What I'm showing on the over here is geometry. To some of you may want to know what the heck is that. If you see the next one is asking you this piece. Watch this. So first step is let's multiply x minus 1 both sides. So you do this side, and you multiply x minus 1 here also. Okay. When you multiply x minus 1 both sides, you can see uh, x minus 1 crosses out. See, what are you left with? X equal. So you get the same thing. So x equals plus minus square root of 1, and the answers are again -1 and +1. Remember, you cannot take, question is, can we take 1? And you can see if you take 1 and plug it in there, so this 1 cannot be plugged in here, see, in the x. Because if you put If you put 1, it will be 1 square over 1 minus 1 equals 1 over 1 minus 1. And you end up getting 1 over 0 is, and that's does not make sense. See? So this is not good. So only answer is, so this is the extraneous solution, but this is the right answer. That's where the graph, they cross each other. Okay, so a lot of maths there, hopefully. Okay, watch this. Okay, so you are given, here are a lot of equations. For each one, use what you know about division to identify values of x. That cannot be a solution. And you can see the moment you see itself on the left side, 100% you know x minus, when is the denominator is going to be 0? And you can see the denominator is going to be 0 if you do this. You get x equals to, this cannot be the part of the domain. Okay. And also we can use the top one, we can factorize. So if you use the division, it says use what you know about division to identify the values of x that cannot be solutions. And that means is, if I divide this way, x square plus x. Can everybody try what I'm talking about? This, some of you forgot it. So if you do divide, what do you get here? So x times x is x squared, if you remember, and then if you multiply here, you get minus 2x, and then subtract. So many of you forgot this, right? So if you subtract, this become 3x here, and drop the minus all this, and then again x times 3 see, is 3x, okay? And then again 3 times this 3 back multiply here, we get minus 6. So when you subtract, you switch the signs, minus and plus, we get 0, see? And so beautifully the remainder, what does this mean? The remainder is 0. Is 0. What that means is, when the left side, when we divide, we get up, this piece is the quotient. So many of you forget, right? So this is the quotient. The remainder is 0. So this whole thing becomes, the top part, we have two factors. Uh, the, and the two factors are, so this is the divisor. Actually, what it means is, it is x minus 2 and x plus 3. So when you multiply these two pieces, that's what you get, and you just cross out this, and you end up getting x plus 3. So you could write directly from here to here, because when you divided this, we got quotient as x plus 3. So x plus 3 is 5. Okay. And when you subtract 3 here, let's say subtract 3, you get x equals 2. And you can see x equals 2, even though it looks, we say it is a solution. No, it is not. So this is x equals 2 is a extraneous solution. And you know the reason is extraneous. This is the word I'm using it one more time. Extraneous solution basically means, it seems to be it is a solution, but it is not, because you can see the denominator has x minus 2. Okay. And if you plug in x equals 2, the denominator becomes 0, and you can't have that. So hope that so that's the, so there's no solution for this. We say that they don't meet the two equations, this one and this one. So there are two equations here, a rational function and also this, they don't cross each other. So we say there's no solution for the A. Let's do the next one. Okay, first step, let's do multiply. You can see there's an x on the left side, there's an x minus 2 on the right side. So both sides multiply by, let me write this, 2x plus 1 and x equals 1 over x minus 2. Okay, but when you look at it, you already know you can't have, you see. So the first denominator is x equal to 0 is, if we can't have x equals to 0. The second case, x, these are the two numbers cannot be the in the domain. When I say domain means x cannot be those values. Now what we will do is multiply both sides by, so multiply both sides by the least common denominator. So one of them is x is there, and there is also x minus 2. So you multiply both sides by this x minus 2, and the other side you multiply by also multiply by x minus 2 and also x both. Okay. So when you do this, you can cross out, the x will cross out. So this x and this x crosses out, and this x minus 2 and this x minus 2 crosses out. So what are you left with is uh, x minus 2 over. Okay. Now we need to do a little work here. Is see, we could also use the distributive property. So those of you who forgot, you can do this way also. I put x minus 2 like this. And the second one is 2x plus 1. So if you multiply, use the box method, you can see it. This is how it works. You guys have done this, but you forgot. So that's 4x. Okay, and this is minus 2. So this whole thing reduces to 2x squared. Then combine the like terms, and you can see there's 1 plus 1x and the other one is minus 3x. So minus 4x, so together becomes minus 3x and then minus 2. So at the same time, we can subtract x, this is x, and then you subtract x this side and this side to get 2x squared minus 4x minus 2 equals 0. Then we can see that we can always divide by 2 all of these numbers. We get 2, and you get x squared minus 2x minus 1 equal to 0. Now this one we'll have to use quadratic. Now let's see whether can you'll see we can't factorize this. So this piece is not possible to factorize. So what we're gonna do is we can use a quadratic formula. So many of you forgot. So this is the quadratic formula. Divide by 2a. So those of you forgot. So that means a is 1, the number before x squared is 1, b is minus 2, and c is minus 1. So using the quadratic formula, this becomes minus of minus 2 will be b 2, then plus or minus. And if you try to work this out, separate b square minus 4e minus 4, 1 times minus 1. You do little scratch work like this, you'll get 4 plus 4, which is 8. So this becomes square root of 8 divided by 2 times 1. So now we can, there's another, what is the meaning of, how do we find square root of 8 can be written as square root of 4 times 2. And if when you separate it, square root of 4 is 2, but the root 2 stays the same. So this could be written as 2 plus minus 2 root 2 divided by 2, and you can cross out this 2 and this 2. See? So what I left is 1 plus and minus root 2. Another way to do is look at this problem. We had done this long back, but you must have forgotten. This is about boating upstream, downstream. Upstream going, then you know the speed gets distance over speed was the time. If you remember, that was the same problem. So what you do next is here we can do use the cross product like this, and let's use this idea here and use the cross product. So what does this basically means? Actually, we are skipping one step here. We are multiplying both side by, so it's like this. Instead of writing this long step here, so both side you're multiplying by x plus 8 and x minus 8. So if you multiply on the left, you have to also multiply the least common denominator is this. So then eventually x minus 8 crosses out, x plus 8 crosses out. And instead of doing all this extra work, that's why I say, okay, let me take whole thing and start fresh. All you do is just multiply this. This is like a shortcut called cross product. Now what is cross product is, that 10 multiplies to x minus 8, and the 5 gets multiplied to x plus 8. See? So this is like skipping, we are skipping one step here. What is that we are skipping is uh, uh, the least common denominator multiplying both sides. That takes too many steps. So we do shortcut like this. But before even you use the distributive property, we could divide this by 5. It makes it more easier. Divide by 5, both the side. What you get is 2 into x minus 8 equals x plus 8. So simple. And then when you use the distributive property, you get 2x and minus 16 equals 1x plus 8. So subtracting 1x this side and this side, you get 1x minus 16 is 8. And adding 16 both sides, we get x equals 24. So I hope 2x, I just want to make sure the steps are correct. X plus 8. Okay, so that's the answer. So you get x equals 24. So it's, in other words, it's like, uh, first of all, we want to make sure this is unvalid when it is x is minus 8. This is unvalid when x equals 8. So, but then we did not get that those numbers, so we don't have to worry about extraneous solution. So this is the solution, x equals 24. Okay, so let's do the last three and we are done, I think. Okay, look at this piece. I think did the G, okay, I think G we did, right? So this is already done, the last two. Look at this piece. So you can see the denominator that you see here for each problem is one is, so what are the, this is how you do it. So the denominators are x minus 3 and the other denominator is x, right? So that means you put them equal to 0 and you get the answer when you solve it. So when you add, so when you add plus 3 this side and plus 3 this side, this crosses out and you get x equals 3. See how beautiful? This is already done for us. So these are the two pieces cannot be solution. Cannot be solution. It means they are like vertical, we call them vertical asymptote. Vertical. It means when you, if on the grid, what it means is the y-axis itself is like a vertical asymptote, and at 3 there is also another vertical like this. So this dotted line that I draw is, that's what that means. These are the two pieces. If you want to see even the graph, we could we could also, the first one is like this. So the first one, x 1 over x minus 3, this piece is this one. So that's what that means. The second one, we have to separate it at 0 and 3. So there are two asymptotes for the other one. So don't worry about that now. Let's do the last one. Erase all. And you can see here, oh, that's already done for us. See? So the denominator here, denominator is, so this piece, the last piece is, you can't have, see, x plus 1 is the denominator. And if I put it equal to 0 and subtract 1 both sides, and you end up getting x equals minus 1. So this cannot be the solution. This be cannot be the solution. And there is also one more thing here. Yeah. So that's all you're supposed to write. And we say that there is a, now if you turn this, I think that's it. So next is